Week 9 lecture part 2 on patterns, pattern making and completing patterns with 2D and 3D shapes. The lesson objectives. At the end of this lesson, you should be able to discuss the importance of learning and teaching patterns, as well as explain the different types of patterns in primary geometry. So we're going to start with some questions. What are patterns? Where can you find patterns, and what's the importance of patterns? So the definition or the meaning of patterns could be either one of this. They are repetition of objects. They are also repetitions of behavior or habit. When you see repeating shapes or size or colors in objects or living things, those are also patterns. And where can you find patterns? We can find them in two places. One is in nature, and another one will be in man-made structures or objects. So what's the importance of learning patterns? Alright, number one, patterns actually help develop spatial sense. And then number two, we can see patterns in nature. We can see them on animals, where they use it to camouflage themselves from their predators, and the predators also camouflage themselves from their prey. And the animal use patterns to attract mates, to blend in, okay, and also for their offspring to find them. Now, another importance of patterns in nature is that there is a pattern where animals migrate from one place to the next in search of food, water, and also mate. And they will follow the same pattern year after year. For example, the great migration of wildebeest in East Africa. And also in nature, we can find weather patterns like the sunrise and the sunset, and then patterns in 4 seasons, etc. Because based on the patterns, we can actually make predictions of the future weather patterns or the future seasons, and so on and so forth, based on our observations. Here's an example of patterns where it is the migration, the great migration of the wildebeest in East Africa. This is the map here, and this is the wildebeest. Okay, if you want to watch the YouTube video, you can watch it here. That's a link. They see patterns in the great migration of wildebeest in East Africa. So you can actually see it starts in February over here, and then March they are here, and then April they are somewhere in Serengeti, and then in May they have to cross rivers, big rivers, and some of them would actually become the food source for crocodiles. And June they will be here. They actually follow the rain because they need grass to eat. So wherever the rain is, the grass will be greener, and there will be more grass for them. Okay, and July is here. Now this Mara River is very famous because there are lots of casualties where the wildebeest will fall prey to the hundreds of crocodiles in the Mara River. August, and then October they will be, September they will be here. October, and then November they will be back here. They will be going through other rivers as well. And then December, and they will be back somewhere here in Ngorongoro, okay, in January, right? So the cycle actually goes on, and this is a type of pattern. And based on this pattern, scientists can actually predict where the migrating herd would be in each. Alright, another importance of patterns will be to identify similar buildings such as the pyramids, which can be found on land as well as in the water throughout the world, and it's not only found in Egypt, but underwater it was found somewhere in the Bermuda Triangle and in Japan, somewhere in Japan as well. The patterns actually help scientists to detect anomalies in the weather patterns. Okay, anomalies such as suddenly there's hurricane, suddenly there's a storm, so they would be able to detect the anomaly. And sometimes flash flood, mud, flood, and then places where they have never been snow and now it's snowing, places like deserts where it was previously bare, okay, suddenly you have vegetation. So that is anomalies. And then to also catch criminals such as drug traffickers, serial killers, pedophiles, and thieves, etc. So because all these people and human beings, we are we follow a certain habit, and that habit is becoming a pattern in our life, or we call it routine. For example, you wake up in the morning, you go to the bathroom, you brush your teeth, you take your shower, and then you had your breakfast, and then off you go to the university. So you study, and then you come back home, and then you have dinner, and after dinner you'll be relaxing for a bit, for example watching Netflix or listening to music, and after that you go to sleep, and then you wake up early in the morning. So that is a routine. And since it's a routine, it is also a pattern. So your mom will actually know what time you will normally wake up, what time you will normally go to sleep, what time you will have your dinner, what time she can expect you home from the university. Right, so patterns are not only shapes or colors or sizes that we see. It is everywhere in the world. It's just that you need to show it to your students and also help them to see where they can find patterns apart from their geometry textbook. Why do we learn patterns? The obvious answer will be that patterns are all around us, and finding and understanding patterns give us great power to predict. Okay, to predict. With patterns, we can learn to predict the future, we can discover new things, we can better understand the world around us. So when you predict the future, for example, it is predicting weather pattern, economic pattern. Is it healthy or unhealthy? Okay, and due to COVID-19, most of the people are without jobs, without salary, and some they have been without food for a long time. They need help. The economy is suffering for some countries. So that is pattern. And discovering new things like the breeding patterns of whales, okay, the breeding patterns of penguins, for example, the emperor penguins, they can only be found in Antarctica. And to better understand the world around us through studying the pattern. There is always pattern somewhere. You just need to find it. Right, so here is a link for simple patterns that you might want to take a look at. Power of patterns. Children naturally recognize patterns within the context of their day activities. Day activities, that means from the time they wake up to the time they go to sleep. So for example, they are so used to their daily routine, and they actually know what comes next. And if you try to change the sequence, the daily sequence, the child might say something like, no, a nap comes after lunch, not before lunch. Okay, so that means the child actually recognizes the patterns or the routine. You know that this growing awareness is a critical building block in their mathematical reasoning, the learning of patterns. Okay, learning of patterns. Studies have shown that encouraging a child's understanding of patterns will contribute to their counting strategy development, problem-solving generalizations about number combinations, and algebraic thinking. This is by Copley, 2000. Okay, when you explore patterns, your math brain actually grows. There are many natural opportunities for pattern play with children every day. There are a few ways to enjoy this important math building skill. We have two parts, where first we find the patterns, then we create patterns. So let's find patterns first. Now, when you want to find patterns, children will be able to identify repeating patterns naturally. They will see something that occurs in the environment, okay, such as stripes on a shirt, red, yellow, blue, red, yellow, blue, okay, or the bricks or stones by the roadside, where it is this one is, let's say, black and white, and then black and white, so they can see the pattern there. You can also help them by stating out loud a pattern that you have noticed, and then ask them to try to find where it is. So children may also tune into repeating patterns of sounds. Sounds can become patterns as well. For example, loud, loud, soft, 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 loud, loud, soft. Okay, even the pitter-patter sound of the raindrops is a repeating pattern. So sound of windshield wipers or other sequential rhythms. So you can bring in, if you're using an iPad, for example, you can use GarageBand, where they have the instrument, so you can a musical pattern actually. So it will be fun, and ask your students to create musical patterns using their iPads and GarageBand as well. Keep an ear out for patterns in songs. For example, the song for kids, head, shoulders, knees, and toes. So you can play that song, and then you ask them to find the repeating patterns in the song. Alright, for creating patterns, you can encourage your students to create patterns by arranging colored blocks or crayons or different sized objects, or stringing beads and more. Okay, stringing beads, making a bracelet or a necklace, that would be fun for the girls. Okay, you can also invite them to create patterns in their physical movement, okay, such as jump, jump, clap, jump, jump, clap. So you can do this as well. So this would be fun. Assign them into groups, and that each group must have their own movement. So you have to have 3 movements, for example. So they can roll their hands, wriggle their nose, and so on and so forth. So you are encouraging them to create patterns. You can ask them about the patterns that they created, okay, or they are creating. This will encourage your students to explain the patterns they created. That means they would be able to justify, okay, why they created those patterns. So here's an example of jump, jump, clap. Now you have to remember, when children actually create their own patterns, they may follow the pattern for a while and then they change suddenly. For example, they created this pattern, yellow block, orange block, yellow block, orange block, and then suddenly there's a blue block. Okay, so when you ask your student why is it that you put in the blue block, the student or the child would just say, oh, because blue is my favorite color. And children don't need to be corrected every time that they don't follow the pattern rules, but you could say, if I were doing this pattern, I'd probably keep going with yellow block and orange block. That is another way to approach kids, where you don't tell them directly that they're doing it wrongly, but you just say, like, if I were you, I would do it this way. Then that will make them think at that point. So this will encourage discussion that reinforces pattern making concepts. Okay, you could also ask questions, probing questions. And here are some examples. Okay, number 1, do you see a pattern? Can you tell me about it? Okay, number 2, what comes next? Could you make a pattern with these different materials? Number 3, how could we make a picture that would help us remember this pattern? Number 4, can you show me a pattern with your body? What would you do first? Second. So this is the body movement just now. Okay, number 5, what happens over and over again with these blocks? Okay, number 6, how would you read this pattern? Number 7, what would happen in the pattern if I changed? Okay, so you change the color, then the child will rationalize, okay, no, not that is not correct. There are many natural opportunities to explore patterns with your child on a daily basis. So enjoy these important mathematics skills together. Now here is a research paper on patterns by Ros Garrick, School of Education, Sheffield Hallam University. So this paper was presented at the annual conference of the British Educational Research Association, University of Exeter, England, 12th to 14th September 2022. So this is the link to the actual paper, so you can have a look at it. But what I'm going to discuss with you will be what's in the paper. Okay, so Ros Garrick actually look at students of 3.5 to 4.5 years old at a nursery in the United Kingdom. So the data that Ros Garrick collected was focused on these points. Number 1, children's competencies in spatial pattern making. Number 2, the relationship between representational and pattern making competencies. And number 3, children's talk about pattern. The researcher actually looked at assessment activities for the overlapping studies, incorporated 2 different play materials, providing for the possibilities of both linear pattern and also 2-dimensional pattern making or pattern playing. We're going to look at linear pattern a bit later. Now these are mosaic tiles used with Duplo strips, packs and packboards. These are example of packboards where there are holes and then you're given this packs and then you just put in to form a shape like this or like this one and so on. Now children, when they work with the mosaic tiles is the Van Heel mosaic tiles, you can Google for it, were invited to make a pattern, initially without adult model and then following an adult model of linear organization. So the researcher also looked at placement order of tiles, which was recorded. So we talked about linear pattern just now. So this is actually the linear pattern. Linear pattern is actually numbers. Patterns found in numbers. There are certain rules that you need to follow when you look at linear patterns. The first one is that each number is called a term. This is a term, this is a term, this is a term, this is a term. So the first term is 2, the second term is 5, etc., etc. The gap between the numbers is what we call as the difference. In this example, the difference is 3, okay, because 5 minus 2 is equals to 8 minus 5 is equals to 11 minus 8, which is 3. So the gap or the difference is 3. Now in linear patterns, they may have the same difference between the terms. So to find the rule, we have to look for a relationship between the numbers and of the terms and the term itself. So the rule is the same for each term. In an example here, 2 equals to 3 times 1 minus 1. 5 is 3 times 2 minus 1. 8 is 3 times 3 minus 1. So the rule is T equals to, T is the term equals to 3 times n minus 1, or equals to 3n minus 1. So you can watch this video here to learn more about linear pattern. Now for 2D patterns, we have several types. There are 4 patterns that as teachers we need to know. The first one is the ABAB pattern. So ABAB, it could be shapes and colors. Okay, so for example, a square, and then a triangle. Okay, and then a square, and then next is a triangle. This is an example of an ABAB pattern. So A is square, B is triangle. The second one is ABC pattern, where you can include shapes, colors, and direction. So take for example, this is red. We're looking at colors. A red square, okay, a blue triangle, because it's 2D, okay, and the next one is a rectangle. So each one is an A, this is a B, and this is a C, and then it repeats. So if you're looking at, this might be shape and colors, direction will be that way. You can combine 2, or you can combine all 3. That means there's different shapes, different colors, and different direction. Now the next one is patterns 3. So we have ABB, we have AAB, and we have ABA. Okay, so this one will be with shapes. Let's see, this is a square. This is a square, which is an A, and B is the triangle. So if it is ABB, then A, B, B. AAB, that means there will be 2 squares, 2 red squares, and 1 triangle. And ABA, that means there will be 1 square, and then we have the triangle, the blue triangle in the middle, and then we have the red square again after the blue triangle. Right, patterns 4, we have a slightly longer combination: AAB, AAAB, ABBA, it's like ABBA, okay, and ABCD. Right, so yeah, for this one it's the same. So let's say we're using red squares. So this is A, this is A again, and then AABB, that means the triangle, the blue triangle, and the blue triangle. So this is AABB. So you can actually watch some different combinations in the links here to get an idea of the 2D patterns. In the research, children were similarly invited to play with packs, so packs and packboards, and they are requested to answer this question: can you make a pattern with the packs? So the positioning of the packs and placement order was actually recorded. So when children paid attention to the color of packs, colors were recorded. So if they mentioned that I'm going to make a yellow square, so they use all the yellow packs. Okay, but if they didn't mention the color, then it's just the shape. So conclusion of the research done by Ros Garrick is that according to Booth 1981 study shows patterned configuration in older children. This study found that pattern configuration is also in much younger children. Now, the study does present evidence of some children attempting to make sense of the word pattern. Okay, of the word pattern during self-directed work with packs. So they keep on saying, I'm going to make this pattern, I'm going to make this pattern, I'm going to make this pattern. It's as though they are reassuring themselves. Okay. So since the children are inquisitive and they ask the question, what are patterns? And that is our next topic. Pattern as a mathematical concept is a concept with wide application. Are defined as repeating shapes or size or colors in objects or living things. And example will be living objects, for example, stripes on a zebra. And patterns can also be a repetition of shapes and numbers. So actually it's things, objects, 2D, 3D objects, which can be repeated and can be turned into patterns. So each pattern will follow what we call as the core pattern. A core pattern. So for example, black circle, red circle, black circle, red circle. So the black and red circle, the first two, are the core patterns. So pattern can be classified into simple patterns and number patterns. So simple patterns will be those patterns which involve shapes or sizes or colors. And number patterns will involve numbers, or what we call as linear number patterns. Okay, so you can watch the YouTube video here which explains what patterns are. So what are simple patterns? Simple patterns are created from 2D shapes or 3D shapes and colors, and some they put sizes. Okay, sizes. So it could be a small square, a big square, a small square, a big square. This is an activity which you can actually ask your students to do, which is to create simple patterns using 3 items. For example, shapes, size, and colors. So that means you'll be creating 3 different patterns. This is pattern number 1, this is pattern number 2, this is pattern number 3. Alright, number patterns or linear number patterns, we have 2 types. The first one is what we call as arithmetic sequence. Second is geometry sequences. You can watch the video here. The video will actually explain to you what is arithmetic sequences and what is geometry sequences. The definition: an arithmetic sequence is made by adding or subtracting the same value each time. So arithmetic has something to do with the plus and the minus. Geometry sequences, so a geometric sequence is made by multiplying or dividing by the same value each time. So for geometry, it will be times and division. Okay, so for arithmetic, it will be plus and minus. So find a way for you to remember which is which. The number patterns or linear patterns, we have so many types, so many sequences. So the first one is triangle numbers. And triangle numbers are generated by creating triangles of progressively larger size. So this is 1, and then you add 2 at the bottom. Then you add more at the bottom. So you put it 1 and then the next 2. You don't put it this way, then this is not going to form a triangle, so it must form a triangle. That means you have to put it in certain way. The next one is square numbers. So square numbers are whole numbers, means 1 times 1, 2 times 2, 3 times 3, 4 times 4. Then you will have 5 times 5, 6 times 6, 7 times 7. Now the next one will be cube numbers. It will be 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and 4 times 4 times 4. Then we have 5 times 5 times 5, 6 times 6 times 6, or 7 times 7 times 7, and the list goes on. Now the next one is Fibonacci numbers. The sequence is found by adding the two numbers before it together. So for example, this one here is 1. Okay, because you didn't have any numbers before 0, and so you can't get this number here. Okay, so, but you can get the number 1 here. That means 0 plus 1. And for 2 here will be this 2, 1 plus 1. And for 3 it will be 1 plus 2. Okay, and so on so forth. So this is Fibonacci numbers. Alright, you can actually make your own number pattern sequences. For example, here we have a sequence where you use coins or matchsticks. So you can see that you are forming a pattern, a certain pattern. So this is 1 coin. Okay, so the number of the coin and the value of the coin must be the same. So this is 1, and then because you want to add 1 on top and 1 at the bottom, so you add more, and then you add more, and then you add more. So they are looking at the number of coins and not the value. Okay, this is another one, another pattern sequence where you are forming a square. So then you can keep on adding. So you will have 1 coin, 4 coins, 8 coins, 12 coins. Okay, so you can add on to this. Number patterns or linear number patterns, you can actually make your own number patterns. And here's an example of the Pascal triangle. So you can have a look at the link here to know what is a Pascal triangle. Technology in teaching and learning patterns help students who are academically challenged to grasp number patterns, linear patterns, or pattern itself. Okay, so you can use videos and you can create your own videos when you do flipped classroom. Flipped classroom, where students actually learn about patterns at home, and when they get to class, they get to actually do hands-on activities. For example, create their own patterns, answer questions in handouts, and so on and so forth. And for videos, you have several videos over here which we have seen some of them, and also you can use softwares or applications or apps. Okay, and here are some apps which you can find in the Apple iPad store, just in case some of you are going to teach in a school where they are using one-to-one iPad. So you can actually take a look at some of these resources, the apps. Okay, some are free, some are paid, but you do need to go through the apps first. If your school already has pre-installed apps in your students' iPads, then just use those. Okay, here are some links to fun activities on pattern making. So you do have pattern activity, how to teach patterns, example of a lesson plan on teaching patterns, functions, and algebra for elementary school teachers, and also online game. Okay, so you can use this online game you can use this online game for your activity. And for patterns, we're looking at Van Heel. So the students actually will be level 0 to level 2 again. Okay, so how do you design an activity or design a lesson for patterns from at level 0 and then level 1 and level 2? So here's an example. Okay. So this is a self-assessed Kahoot quiz. You can try your hand at it, but there is a time limit. It's only until Friday 19th, 12 p.m. So once it's Friday 19th, 12 p.m., it will shut down or deactivate itself. The pin number is here, so just click on the link and try out this self-assessed Kahoot quiz. And here are some more resources.